Ethylene glycol is an organic compound primarily used as a raw material in the manufacture of polyester fibers and fabric industry, and polyethylene terephthalate resins used in bottling. A small percent is also used in industrial applications like antifreeze formulations and other industrial products. It is an odorless, colorless, syrupy, sweet-tasting liquid. Ethylene glycol is only weakly toxic, but cases of poisonings are not uncommon. Very small amounts of ingested antifreeze can be fatal. Production: ethylene glycol is produced from ethylene, via the intermediate ethylene oxide. Ethylene oxide reacts with water to produce ethylene glycol according to the chemical equation, C2H4O plus H2O CH2CH2OH. This reaction can be catalyzed by either acids or bases, or can occur at neutral pH under elevated temperatures. The highest yields of ethylene glycol occur at acidic or neutral pH with a large excess of water. Under these conditions, ethylene glycol yields of 90% can be achieved. The major byproducts are the ethylene glycol oligomers diethylene glycol, triethylene glycol, and tetraethylene glycol. About 6.7 billion kilograms are produced annually. A higher selectivity is achieved by use of Shell's omega process. In the omega process, the ethylene oxide is first converted with carbon dioxide, CO2, to ethylene carbonate to then react with water in a second step to selectively produce monoethylene glycol. The carbon dioxide is released in this step again and can be fed back into the process circuit. The carbon dioxide comes in part from the ethylene oxide production, where a part of the ethylene is completely oxidized. Historical aspects and natural occurrence: although almost all sources state that French chemist Charles-Adolphe Wurtz first prepared ethylene glycol in 1859, he actually first prepared it in 1856. He first treated ethylene iodide with silver acetate and then hydrolyzed the resultant ethylene diacetate with potassium hydroxide. Wurtz named his new compound glycol, because it was intermediate to ethyl alcohol and glycerin. In 1860, Wurtz prepared ethylene glycol from the hydration of ethylene oxide. There appears to have been no commercial manufacture or application of ethylene glycol prior to World War I, when it was synthesized from ethylene dichloride in Germany and used as a substitute for glycerol in the explosives industry. In the United States, semi-commercial production of ethylene glycol via ethylene chlorohydrin started in 1917. The first large-scale commercial glycol plant was erected in 1925 at South Charleston, West Virginia, by Carbide and Carbon Chemicals Company. By 1929, ethylene glycol was being used by almost all dynamite manufacturers. In 1937, Carbide started up the first plant based on Lefort's process for vapor phase oxidation of ethylene to ethylene oxide. Carbide maintained a monopoly on the direct oxidation process until 1953, when the scientific design process was commercialized and offered for licenses. Uses: e.g. is primarily used as a raw material in the manufacture of polyester fibers and fabric industry, and polyethylene terephthalate resins used in bottling. A small percent is also used in other applications such as antifreeze formulations and other products. Dewatering agent, e.g. is used in the natural gas industry to remove water vapor from natural gas before further processing, in much the same manner as TEG. Coolant and heat transfer agent, the major use of ethylene glycol is as a medium for convective heat transfer in, for example, automobiles and liquid-cooled computers. Ethylene glycol is also commonly used in chilled water air conditioning systems that place either the chiller or air handlers outside, or systems that must cool below the freezing temperature of water. In geothermal heating cooling systems, ethylene glycol is the fluid that transports heat through the use of a geothermal heat pump. The ethylene glycol either gains energy from the source or dissipates heat to the source, depending if the system is being used for heating or cooling. Pure ethylene glycol has a specific heat capacity about 1/2 that of water. So, while providing freeze protection and an increased boiling point, ethylene glycol lowers the specific heat capacity of water mixtures relative to pure water. A 50/50 mix by mass has a specific heat capacity of about 3140 joules per kilogram, c 3/4 that of pure water, thus requiring increased flow rates in same system comparisons with water. Additionally, the increase in boiling point over pure water inhibits nucleate boiling on heat transfer surfaces, thus reducing heat transfer efficiency in some cases, such as gasoline engine cylinder walls. Therefore, pure ethylene glycol should not be used as an engine coolant in most cases. Antifreeze: ethylene glycol disrupts hydrogen bonding when dissolved in water. Pure ethylene glycol freezes at about a 12 degree Celsius, but when mixed with water, the mixture does not readily crystallize, and therefore the freezing point of the mixture is depressed. Specifically, a mixture of 60% ethylene glycol and 40% water freezes at a 45 degree Celsius. Diethylene glycol behaves similarly. It is used as a de-icing fluid for windshields and aircraft. The antifreeze capabilities of ethylene glycol have made it a component of vitrification mixtures for low-temperature preservation of biological tissues and organs. However, the boiling point for aqueous ethylene glycol increases monotonically with increasing ethylene glycol percentage. Thus, the use of ethylene glycol not only depresses the freezing point, but also elevates the boiling point such that the operating range for the heat-transferred fluid is broadened on both ends of the temperature scale. The increase in boiling temperature is due to pure ethylene glycol having a much higher boiling point and lower vapor pressure than pure water. There is no chemical stabilization against boiling of the liquid phase at intermediate compositions, as there is against freezing. Precursor to polymers: in the plastics industry, ethylene glycol is important precursor to polyester fibers and resins. Polyethylene terephthalate, used to make plastic bottles for soft drinks, is prepared from ethylene glycol. Hydrate inhibition: because of its high boiling point and affinity for water, ethylene glycol is a useful desiccant. Ethylene glycol is widely used to inhibit the formation of natural gas clathrates in long multiphase pipelines that convey natural gas from remote gas fields to a gas processing facility. Ethylene glycol can be recovered from the natural gas and reused as an inhibitor after purification treatment that removes water and inorganic salts. Natural gas is dehydrated by ethylene glycol. In this application, ethylene glycol flows down from the top of a tower and meets a rising mixture of water vapor and hydrocarbon gases. Dry gas exits from the top of the tower. The glycol and water are separated, and the glycol recycled. Instead of removing water, ethylene glycol can also be used to depress the temperature at which hydrates are formed. The purity of glycol used for hydrate suppression is typically around 80%, whereas the purity of glycol used for dehydration is typically 95 to more than 99%. Moreover, the injection rate for hydrate suppression is much lower than the circulation rate in a glycol dehydration tower. Niche applications: minor uses of ethylene glycol include the manufacture of capacitors, as a chemical intermediate in the manufacture of 1,4-dioxane, and as an additive to prevent corrosion in liquid cooling systems for personal computers. Ethylene glycol is also used in the manufacture of some vaccines, but it is not itself present in these injections. It is used as a minor ingredient in shoe polish and also in some inks and dyes. Ethylene glycol has seen some use as a rot and fungal treatment for wood, both as a preventative and a treatment after the fact. It has been used in a few cases to treat partially rotted wooden objects to be displayed in museums. It is one of only a few treatments that are successful in dealing with rot in wooden boats, and is relatively cheap. Ethylene glycol may also be one of the minor ingredients in screen cleaning solutions, along with the main ingredient isopropyl alcohol. Ethylene glycol is commonly used as a preservative for biological specimens, especially in secondary schools during dissection as a safer alternative to formaldehyde. It can also be used in killing jars. It is also used as part of the water-based hydraulic fluid used to control subsea oil and gas production equipment. Chemical reactions: ethylene glycol is used as a protecting group for carbonyl groups in organic synthesis. Treating a ketone or aldehyde with ethylene glycol in the presence of an acid catalyst gives the corresponding a 1,3-dioxolane, which is resistant to bases and other nucleophiles. The 1,3-dioxolane protecting group can thereafter be removed by further acid hydrolyses. In this example, isophorone was protected using ethylene glycol with p-toluenesulfonic acid in moderate yield. Water was removed by azeotropic distillation to shift the equilibrium to the right. Toxicity. Ethylene glycol is moderately toxic with an oral LDLO equals 786 mg per kilogram for humans. The major danger is due to its sweet taste. Because of that, children and animals are more inclined to consume large quantities of it than of other poisons. Upon ingestion, ethylene glycol is oxidized to glycolic acid which is, in turn, oxidized to oxalic acid, which is toxic. It and its toxic byproducts first affect the central nervous system, then the heart, and finally the kidneys. Ingestion of sufficient amounts can be fatal if untreated. According to the annual report of the American Association of Poison Control Centers National Poison Data System in 2007, there were about 1,000 total cases resulting in 16 deaths. The 2008 American Association of Poison Control Centers National Poison Data System Annual Report lists 7 deaths. Toxicity. Ethylene glycol, antifreeze products for automotive use containing propylene glycol in place of ethylene glycol are available. They are generally considered safer to use, as propylene glycol possesses an unpleasant taste and is converted in the body to lactic acid, a normal product of metabolism and exercise. Australia, the UK, and 17 US states require the addition of a bitter flavoring to antifreeze. In 2012, US antifreeze manufacturers agreed voluntarily to add a bitter flavoring to all antifreeze that is sold in the consumer market of the US. In the environment, ethylene glycol is a high production volume chemical. It breaks down in air in about 10 days, and in water or soil in a few weeks. It enters the environment through the dispersal of ethylene glycol-containing products, especially at airports where it is used in dosing agents for runways and airplanes. It has been linked as a teratogen in certain species of birds. This molecule has been observed in outer space. References. External links, webbook page for C2H602, CDC-ATSDR, TOX facts, ethylene glycol, ATSDR, case studies in environmental medicine, ethylene glycol and propylene glycol toxicity, CDC, NIOSH Pocket Guide to Chemical Hazards, National Pollutant Inventory Ethylene glycol fact sheet, medical information, Arirong Yu Juntso, Xinbin Ma and Jinlong Gong. Ethylene glycol, Properties, Synthesis, and Applications. Chemical Society Reviews 41, 4218 4244. doi, 10.1039 per carat 2 CS 15359 AA.